Good morning, friends. In the last lecture, we have studied the use of tracer technique in the chemical investigations or say chemical reaction mechanism. Today, we are going to discuss and study the another application. Sometime the question will be like that: what is the tracer techniques? Explain the use of radioisotope as a tracer in age determination with dating carbon 14. No, it is a very much useful technique for the determination of the ancient, you can say, uh, things. It is mainly deals with the archaeological branch. Here, the age determination of the archaeological and biological specimens is done. The radioisotope 14C is used to estimate the age of this particular archaeological and biological specimens. 14C is formed by interaction of neutrons in the cosmic rays with 14N in the upper strata of the atmosphere. When this how that radioactive carbon 14 will be formed, that is formed by the nuclear reaction between the nitrogen 14 along with the neutron. What will happen? This will emit the alpha particle, that is a 1H1, or you can call it will emit the proton. Okay, alpha particle is the helium, but it is a proton. 14 in 7 you can see, or say 7 and 14 plus 0 and 1, that is a neutron is bombarded on this particular nitrogen. It will produce this particularly 6C14 C star, that is the carbon 14. That isotope is the very much radioactive along with the liberation of the proton. 14C is negative beta emitter and has a half-life of 5720 years. Negative beta emitters is nothing but the electron emitter. Means 14C star gives you the, again the nitrogen will be given back. 14C is converted into the 14CO2 and utilized by the plants to build up the carbohydrates to the photosynthesis. And these carbohydrates can be consumed by these all living animals. As long as the plants and animals are alive, proportion of 14C to 12C in their bodies remains constant. But in case of the dead plants and animals, 14C in their bodies will decay, hence its radioactivity in the dead bodies will be decreased with time. The time which has collapsed since the death can be calculated by determining the activity of the 14C in the dead body and that of fresh 14C in the atmosphere. The age can be calculated as T is equal to 2.303 lambda into log to the Western in 0.80. T is equal to 2.303 divided by 0.693 into T half into the log to the Western in 0/nt. Where T is the age of the sample, T half is the age half-life period of the 14C, that is a 45720 years. N0 is the radioactivity of the fresh 14C in the atmosphere, and T is the radioactivity of the 14C from the specimen. This is about the use of this tracer technique in the age determination by using the 14C. What is the tracer technique that I already given in the starting? The particular item which is made radioactive is called as label item. The process is called as labeling. These label items are used as a tracers. Activated element is called as a tracer element. The compound containing tracer element called as a label or tag compound. In the technique in which such a tracer element is used called as a tracer technique. Very simple it is. Then you have to write this answer, age determination. Now we can determine the age with carbon 4 dating by the carbon 14. The radioactive, this is the radioactive carbon 14C is used to estimate the age of the archaeological and the biological specimens. Okay, 14C is formed by interaction of the neutron in the cosmic rays with the 14 in the upper strata of the atmosphere. Then 14C is negative beta emitter, or say you can call it as a negative electron, that is a electron emitter, and has a half-life of 5720 years. Means you can see here 14 C star 6 is gives you the back that nitrogen plus electron minus 1 E0. This 14C can be easily converted into the 14CO2 and is utilized by the plants to build up the carbohydrates through the photosynthesis. Photosynthesis. Full stop. Carbohydrates are consumed by the all living animals. As long as the plants and animals are alive, proportion of this 14C and 12C in their bodies remains constant. But in case of the dead plants and animals, 14C in their bodies will decay. Hence, its radioactivity in the dead bodies will decrease with time. The time which has collapsed since the death can be calculated by determining the activity of 14C in their body and that of fresh 14C in the atmosphere. The formula which can be used to calculate the age is nothing but T is equal to 0.303 upon lambda into log to the base 10 N0 upon Nt. What is the N0? Radioactivity of the fresh 14C in the atmosphere, and Nt is the radioactivity of the 14C from the specimen. Then you can substitute for the lambda. Lambda is equal to 0.693 by T half. Then T half is the half-life period of this particular 14C, that is a 5720 years. T is the age of sample. Now we have to see the numerical based on this particular part. The C14 activity of a sample of the wood reported from Egyptian pyramids is 3.3 dpm per gram. If in a living plants the equilibrium value of the C14 activity is 15.3 dpm per gram, calculate the age of the sample of wood whose half-life of the C14 is 572 years is given. Take this formula, T is equal to 2.303 divided by lambda into the log to the base 10 N0 by Nt. Substitute for the lambda 0.693 upon T half. Then you can put all the given values, that is N0 is given, Nt is given, First of all, write down the given things. You have given the T half, then you have given the N0. N0 is the 15.3 and NT is the 3.3. Then take the ratio, take the log, and you will get the answer. That is a 12663.7 years. The sample of the wood is having age 1.2663. It's 12,663 will be the age of this particular sample. Got this point? This is about your another application, that is the age determination of the sample by dating with the carbon 14. Got this point? Very simple it is. You have to please prepare this. See, specific question will be there. 2 applications are there. Out of this, one will be there in the exam. Please prepare it well. If you have any doubt, any problem, you can ask. Got this point? Very simple it is again. You have to write this part when the it is because it is a 5 marks question, and for this 5 marks I again this sufficient point. Okay. In the MCQs the question may be there based on this particular which radioisotope is used for the age determination, that is a C14. How the C14 is obtained? By the reaction of this neutron with the cosmic ray, with that is a reaction of the neutrons in the cosmic rays with the 14N in the upper strata of the atmosphere, means in the nitrogen atmosphere. This reaction happens, this reaction occurs, and it will give you the formation of the radioisotope 14C. Okay, but whatever the 14C is formed, that will be the beta emitter, or it is also called as the electron emitter, has half-life of the 5720 years. You can see there 14C star 6 gives you the 14N star 7 plus minus 1 E0, that is the electron or beta particle has been emitted by this particular radioisotope. Got this point? Very simple this technique is. Then you have to write about this particular thing, then how this 14C will convert it into the CO2 and it will get utilized by the plant for the preparation of the food by the photosynthesis, and this whatever the prepared food is there, that is consumed by all the living things or say living animals. As long as the plants and animals are alive, proportion of the potency and the potency in their bodies remains constant. But in case of the dead plants and animals, potency in their bodies will decay. Hence, its radioactivity in the dead bodies will decrease with time. The time with which lapse or lapse since the death can be calculated by determination of the activity of potency in the dead body and that of fresh potency in the atmosphere. This formula is very much important that you have to remember, and what are the significance of the terms involved in it, that you have to remember. Okay, then we have seen the one numerical based on this particular part. Please go through this numerical. It is very much important. The question, which sorts of the question will be there, that is there, that question, same type of the question, what is the tracer technique, Explain the use of the radioisotope as a tracer in the age determination with dating carbon 14. That question will be there in the exam. N0 and NT. N0 will be in the living and NT will be in the dead. That you have to remember. Here you can see N0 will be in the active sample, it's a living sample you have to take, and for the dead it is NT. Okay. So you can call as this particular atmosphere. This you have to prepare it well. It is very simple thing, very simple application it is. Please try to see this numerical based on this particular part, how we can calculate that particular half life of this sample. Okay, we will stop here and thank you.